What's up, I'm Gemma and welcome back to my channel. In this video, I want to continue walking through the development process for the Igbo Dictionary API. In the last video, I walked you through at a high level the process that I had to undergo to get a PDF, convert it over to an HTML file, parse that data, and then use that data to build out a JSON object that contained word information like definitions, phrases, examples, and more. In this video, I want to walk you through how I took advantage of regular expression to make the searching functionality for the API to be just a lot more user-friendly. Before I get more technical, I want to explain why I'm using regular expression in the first place. The Igbo language takes advantage of accent marks to denote the different types of tones that are present within the language. So officially, there are 4 different tones that are used or recognized within the language, and they're the high, low, falling, and mid tones. And each tone has its own type of accent mark. So the high tone uses the acute accent mark, while the low tone uses the grave accent mark, and the falling tone actually uses an accent mark called circumflex, which I didn't know about before. The midtone is usually left unmarked in a lot of different dictionaries or pieces of writing. Along with the accent marks, Igbo also uses the underdot mark, which is like a little dot that is beneath certain letters like I, O, and U. So because Igbo uses a lot of extra markings, I wanted the search functionality to be super forgiving to beginners who may not know how to use these marks correctly. So let me show you what I mean by this. Let's look at the word biko, which means please in Igbo. It's one of the most popular words. You hear it in every single Nigerian household. And to my knowledge, before I started this project, I thought biko was spelled with no accent marks, just a simple 4-letter word. But then when I took a look into this dictionary, I realized that there was a falling tone accent mark over the O. So if I were to use the API and I just searched biko without the accent mark over the O, I wouldn't get the actual result that I'm expecting because I didn't include the accent mark. But I think that might be a little too harsh for people who may know certain words, but they didn't know that there was an accent mark or an underdot accompanied with that letter. So what I wanted to do to make the search a little bit more loose and forgiving is create a regular expression that checked for multiple types of letters for each letter. More specifically, what I did was I created a utils function that takes in a regular string or a term that a user is searching for. And then for each of those letters, my function is going to check to see if there is a vowel. So when I look at the term biko, I first hit the letter B, and it's not a vowel, so I move over to I, which it is a vowel. So what my utils function is going to do is it's going to replace I with all possible I characters that use accent marks that are valid within the Igbo language. So instead of I, you will see within the square brackets a number of different types of I's that are present within the Igbo alphabet. Then I move over to K, and then I move over to O, and I do the same thing with O as I did with I. So by the end of this utils function, instead of having a simple 4-letter word, I have a way longer, more complex looking regular expression. So now that I have this regular expression, I'm able to use it to check against all terms that are present inside of my dictionary. And if any of the terms match this regular expression loosely, whether the accent marks match or don't match, I'll return that information back over to the user. And I really like this experience because you don't have to rely on your knowledge on accent marks. You can just type in a word and then you get all loose matches to it. The restriction I did put on this regular expression utils function is that if you do provide a letter that does have an accent mark, I'm not going to replace it with all possible vowels of that letter. So let's say that I typed in biko with the proper accent mark over it. The letter I is still going to get replaced with all the possible I's in the Igbo alphabet, but O is just going to be the same because it already is an accented letter. So I'm going to walk you through the technical solution that I came up with for creating these regular expressions. I just want to put a disclaimer out there that this is definitely by no means the 100% right way of writing this out. It's just the best way for now that has enabled the search functionality to be a lot more forgiving for beginners who would want to use this API. So here I have my utilities function called create regular expression that takes in my regular search word. And then what I'm doing is I'm reducing that search word where basically I'm going through each letter in that search word. So for each letter in that search word, I check to see if it's a letter that actually can be accented in the Igbo language. And the way that I make that check is that I take the letter and then I try to index into the diacritic codes object that I created. So this is what the diacritic codes object looks like. Each key in this object is a letter that can take on an accent mark, whether it's a grave or acute or even an underdot. And then the value for each of these keys is a group of possible accented versions of that letter, including the original letter. So each of these accented characters are denoted by their Unicode instead of me literally typing out the accented characters. So the reason why I wrote out their Unicodes instead of literally typing out the accented characters is so that I can avoid any normalization problems. So the thing about the characters that you see on your screen, like the letter M or the letter O, they are represented by something called a Unicode. But the even more interesting thing about characters that are accented is that sometimes they can be made up of two separate Unicodes. So here on the MDN page for the string normalized function, you can see that they have an example for two different names. They have name 1 and name 2. And you can see that their contents are very different. They have two different sets of Unicode values. But if you print out these names, you can see that they look exactly the same, where the first E is actually accented. But if you do an equality check against them, you'll get false. And the reason for that is because the Unicode values that make up these strings are different. So in name 1, you can see that there are less Unicode values. The reason for this is because one of the Unicode values is responsible for rendering out the accented E. But in name 2, you can see that there's one extra Unicode value, which is responsible for rendering the regular E and then the accent mark. So the really unfortunate thing about accented characters on the internet is that some accented characters might be made up of one Unicode, while another accented character might be made of two Unicodes. So back to the code. So when I said I wanted to avoid any normalization problems, I wanted to avoid the possibility of having inconsistent Unicode values. So once I get all of those accented letters, I want to append that to my current regex word inside of my reduce function. And then the final string that is returned from my reduce function is called regex word string. So this regex word string is literally a string that's prepped to be used inside of a regular expression. And you can see on the next line that I'm returning a new regular expression where I'm putting my regex word string inside of the constructor function. So this really unlocks search for a lot of beginners who don't know the language, as well as someone who's a native speaker or who is even like a scholar studying the language. So that's how I took advantage of regular expressions. I realized I really wanted to do something like this because as I was using the API, I realized that I didn't know anything about the accent marks and I wasn't getting the correct or expected terms that I wanted. And so having a regular expression that did a lot of the heavy searching for me was super nice as someone who can just type in the plain basic word and then get all of the accented words back. If you want to check out any of this code, I'll link it in the description box below. If you want to contribute to this project, if you want to build out a feature, if you want to validate any of the information that is posted or powering the API, or if you want to request any new features, you can send me a DM on Twitter, you can leave a comment down below, or you can go directly to the GitHub repo and open up a PR, create an issue, add comments, all that kind of stuff. Any contribution would be super helpful and super welcome, so please let me know what you think. That's it for this video. Thank you so much for watching up until this point. If you enjoyed this video, please drop a like and subscribe to the channel for more content like this and similar JavaScript content. And with that, I'll see you on the next one.